Today we are going to look at curved mirrors. Yesterday we completed plane mirrors, and under curved mirrors we shall look at some terminologies then we shall also talk about images formed by curved mirrors. And under the images we shall consider concave and then convex. And by the end of this lesson, you should be able to understand curved mirrors. Let's first talk about terminologies under curved mirrors. And before I look at that one, when we say curved mirrors, they are formed from a sphere of glass. In case this is a sphere of a glass, and part of this sphere is cut, so that we have something like this. And if the outer part is coated with a silver, just like that of the plane mirror, and the shiny part is the inside, then that's the reflecting surface. We call this concave, or what we call converging mirror. It is called converging because it can converge light rays incident on it. If inside of the curve is also coated with a silver surface, in which the shiny part is the outer part of this particular curve, then it becomes what we call convex, or what we call diverging mirror, because it also diverges light rays incident on it. Okay. Now let's talk about the terminologies. The first terminology I want us to talk about would be aperture. The aperture is the width of the mirror. The width, or let's see, the surface of the curved mirror is called aperture. 2. Let's also talk about pole. The pole is the center of the mirror. If I have a mirror like this, coated, the center, if you are considering this, then that center is what we call the pole of the mirror. P represents the pole of the mirror. Okay. The next terminology I want us to talk about would be the center of curvature. Center of curvature. Mirrors, curved mirrors are formed from sphere, and the sphere has a center somewhere. It means if this is our curved mirror, it may have a center somewhere, provided this will be our center of the sphere. Then the center of curvature is the center of the sphere from which the mirror forms part. The center of the sphere from which the mirror forms part. becomes the center of curvature. We use letter C to represent center of curvature, the center of the sphere from which the mirror forms part. Terminology number 4 we shall talk about will be radius of curvature. Radius of curvature. C. Radius of curvature. It's the distance between the center of curvature and then the pool. Let's have the pool here. That is the center of the mirror, and then the center of curvature. The distance between the center of curvature and the pool is the radius of curvature. 5. Principal axis. Principal axis is a straight line drawn through the center of curvature and the pool. So if I draw a line through the center of curvature and the pool, very long line, then we call this line principal axis. Principal axis. A line drawn through the center of curvature and the pool of the mirror. So we'll talk about focal length. Focal length, I'll use small letter f. It's used to represent focal length. And if I have my mirror like this, and then if I draw my principal axis through, let's go here, the pool, and then the center of curvature. The focal length becomes the exact difference in between, that is the center from the center of curvature to the pool, which we are going to talk about it later. But the principal focus, the distance between the principal focus and the pool, becomes the focal length f. So we can say that focal length is equal to radius of curvature over 2. We shall need this idea when we come to the calculations under curved mirrors. I mentioned principal focus. 6. Principal focus. Principal focus. It's a point on the principal axis where parallel rays, when I mention parallel rays, if I draw my mirror, these are the principal axis through the center of curvature and the pool that will go to this side, are said to be parallel rays, or rays parallel to the principal axis, and all of them reflect to a point on the principal axis called principal focus. So, principal focus is a point on the principal axis in which parallel rays reflect through. These are the most important terminologies I want us to talk about. Now we can discuss images formed by curved mirrors. Images formed by curved mirrors. Images formed by curved mirrors. Images. Images formed by curved mirrors. And before we study the images formed by curved mirrors, we need to follow some principles. And these are the principles we are going to use to draw images, how images are formed by curved mirrors. 1. You should know that all paraxial rays, when I mention paraxial rays, I mean rays parallel to the principal axis. The ray is parallel to the principal axis, it reflects through the principal focus. And again, the rays through the principal focus also reflect parallel to the principal axis. So if I draw a ray also through the principal focus, it will also reflect parallel to the principal axis. 2. Rays passing through the center of curvature. I have this as my mirror. Principal axis. If the center of curvature is here, it means all rays passing through the center of curvature, rays passing through the center of curvature reflect back along the same path. Three. If I have my curved mirror like this, with the principal axis, if here is P, this side is my center of curvature. A ray incident at the pole reflects, making the same angle to the principal axis. So if here is theta 1, then the theta 2 here will be the same. That is, theta 1 will be equal to theta 2. That is, if the ray is incident at the pole, it will reflect, making the same angle to the angle of incident ray. If this is the incident ray, then the reflected ray, the angle theta 1 will be equal to theta 2. Let's talk about images formed by concave mirrors or converging mirrors. Let's talk about concave. If I draw my concave and I coat my silver surface, it means we are looking at the inner I have my pole, my center of curvature here, then the principal focus also here. The first image form, this time around, let's see object O beyond C. That is, object is plane beyond C. Let's place our object somewhere here. Objects. Then we follow the rules. Rays parallel to the principal axis. Reflect through the principal focus. And rays passing through the principal focus also reflect parallel to the principal axis. where the two rays intersect, they intersect at this point. We said that the image will be formed at that particular point. So here will be the image. And you can see the characteristics of the image. The image will be inverted, and it will also be rare. The rare image is formed because it is formed due to actual intersection of the rays. That is when the object is placed beyond center of curvature. So, as you can see, when an object is placed beyond C, then you obey the rules. Rays parallel to the principal axis reflect through the principal focus. And rays passing through the principal focus also reflect parallel to the principal axis. And if you follow the other one, it also means that if I draw this ray here, then it will also reflect along the same axis. And where the two rays of the image intersect, the image will be produced at that particular point. In our next video, we shall continue images formed by concave mirrors and then convex mirrors. And if you have any problem, you can call my number 02087176604, or you can contact me through my email ikebuanti@yahoo.com. And again, you can also meet me online on every Tuesday from 4 o'clock p.m. to 6 o'clock p.m. Thank you very much. Okay, Tuesday, you can meet me on 4 o'clock p.m. to 6 o'clock p.m. so that we can talk more about our physics videos that you have watched. If you have any problem at all, you can contact me there. Thank you.